Hello everyone, welcome back to the series of the computer science subject of the 12th standard in Tamil Nadu. This is the fifth video which I'm publishing and it is about chapter 5 where we are going to discuss about Python programming. This is part of Unit 2 and there are more chapters in Unit 2 and I'm planning to release more videos around them in coming weeks. So we finished Unit 1 in last 4 videos and it's the slide you're seeing now is a summary of those chapters. I thought I'll give a quick overview before we go into this chapter 5, which is about Python. So in chapter 1 we discussed about function and what is a function, which you all know by this time. It's a function is made of one or more subroutines, and one or more functions form a programming language, and the algorithmic statements play a basement for any programming language. To find more about function, please go and play the video 1 about that, chapter 1. Secondly, we discussed about data abstraction. What does that mean? In abstraction in general hides the details, but it only provides the essentials to the outside world. That's the normal meaning of an abstraction. But in data abstraction, it actually helps programmers to treat code as objects. And from the object definitions, we can derive other properties. Please visit video number 2 to see more about data abstraction. The third topic was about scoping, and it refers to the visibility of variables, parameters, and functions in one part of a program to another part. So we touched about declaring variables in a local mode, global mode, etc. in a programming way, especially how to do that in Python in video number 3. And in video 4, I have discussed about the algorithmic strategies, which are kind of more detail about what an algorithm is and how it's used, how it's important. And as we all know, it's a finite set of instructions to accomplish a particular task, and it is actually also a step-by-step procedure which helps the computer to solve a given problem. To know more about algorithmic strategies, which is about Unit 4, please visit the video number 4. And at this junction, I will also request you to forward or share the video links of all these 4 chapters to your friends in 12th standards, as well as if there are any 11th standard students who are going to start looking at 12th standard syllabus after a couple of months. Okay, and let's move on to the Python chapter 5. So in this chapter, we are going to mainly focus on the key features of Python and discuss about its the different types of data types and types of operators and how the variables and expressions occur, etc. with some examples. Um, I want to mention something important at this point. Any type of programming, doesn't matter is Python or any language, it's very important to understand the concepts first and then the basic elements of that program. So until chapter 4 we have talked about general concepts, but from chapter 5, as per your syllabus, they have taken Python as the programming language for educating all of you, which is mean it's important you understand from this chapter onwards all the important elements which needs to write a program successfully using Python. Okay, so you can see that Python is quite popular now. I mean, I have seen in companies, and many companies, Python is used for different purpose. Especially, it took a big hit last 5, 10 years, 5 to 10 years. Um, and and Python is used for many purposes. Um, though it was used as a general purpose programming by Guido van Rossum, um, and it in 1991, where he helped to release that programming, it took a while to get to the stage where it is today. Unlike the programming languages like C, C++, Java, Python took its time to come to market and used widely by a lot of people now. It heavily supports object-oriented programming approaches, which is where we discussed about classes, definition of an object, etc., in other chapters. Okay, so Python has something called IDLE. Nothing but it is nothing but a place or an environment where you can develop as well as run the Python code. For every programming language, you need some kind of environment or a location where you can do development, meaning where you can write the program as well as test the program as well as run it to see the, to see the outcomes you want in that program. So similarly, Python also use something called IDLE, and it's called Integrated Development Learning Environment. And the python.org, www.python.org is the standard website. Anytime you go there, there are tons and tons of materials about Python, and including what releases they have, what version they are releasing, as well as what features are available in each of the version. When I checked it last week, I found 3.10.6 was the latest version, and I'm sure there is more new version coming. So basically, this version changes. This happens to other programming languages too. There is not like one programming language and then it just stays with one version. It always improves. So every programming language get improvement over months and years, because every time in general public we want to solve some complex problem, so a programming language should also help to support to solve that problems, and hence constantly there will be improvements in the programming languages too, and hence these versions are important, right? Because you should understand why version is important in any programming language. Same concept applied to even databases too. So always you won't be in one version, 30, 40 years ago, whatever database version was found, it's not anymore relevant. Always there are new versions. Okay, let's focus on the key features, right? Your book has got a compiled list of that. I thought I'll show you in a simple picture and called out the key points. We all know that it is a platform independent programming language. So what does that mean? Okay, platform meaning, okay, there is a program, but it needs to run on some computer, but that computer doesn't work if it doesn't have a operating system, right? So for that, if it's Windows platform, let's say Microsoft Windows, you will install in your computer, and then on top of it, if you want to run Python, it will work. So same way if you put on a Linux, um, or you have an Apple computer, there is tons of operating systems, but there are common ones. Definitely, Windows is a common one, widely used. Um, but irrespective of the platform where you are in, Python will work. This why it's called platform independent. As well as it's easy to read and understand, and that is true because it doesn't have complex programming statements and stuff like that. There are some fundamental things you need to know about the program, but as you practice more, it's very easy to write programming using Python actually. And the if you see in the picture, it also talks about other features, like it supports interactive mode, meaning it you can actually run the Python programming in two different mode, which we'll see in the next slide. So it helps to even test easily for early beginners of learning a Python program. And also it's very compatible with any type of databases. So databases mean where without database you can't store the data, as you know. So it works very easily with them. And when you say GUI is the graphical user interface, meaning this is like a website, let's say. So you can design website and then make sure Python is also embedded in that and working with that to get the data through a website and then pass it to the database. So it is like any other Java type of programming. It is quite powerful. So that's something one you need to know. And the last one is it's free. That's because and open source. Okay, this is something new concept, but just in knowledge for knowledge I'm sharing this. So not all software programs are free. Okay, so if you are buying certain software programming languages, you need to pay money to even use those programs and build using them, or do development of programs using those programming languages. But Python is free, so anyone can go and download it, and such ones are actually classified under open source. And a lot of open source ones are quite popular because of it's while it's cheap, so a lot of people will be obviously trying to use such solutions as well, or use such programming languages for their solutions. Yeah, so that's what it's called, free and open source in that picture. Okay, so let's move on to the next slide. So this is important. So if there is a question about what modes of programming is used in Python, your answer is very simple. So it does have two modes. One is called interactive mode, which helps to write code in command prompt. So you would have seen this in your labs, or when you try in your computer, you can try this, right? It's very straightforward. So it is called interactive mode because you are able to interact with that screen and then type in the commands you want, and then you will get an answer immediately, a feedback or an output, right? This type of interactive mode programming is common. I mean, it's not only in Python. There are a lot of other programs also have that a feature, and it's very common in IT field where a lot of people we learn to use command prompt based queries. Some people do that, especially people who have worked in IT for 20 plus years. They definitely know how to use command prompt type of solutions. Okay, so that's something for you to know, but it's used for a certain purpose. Let's say if you are writing a million line code, or let's say it's a very large program and which has got complex procedures, subroutines, and sub functions, etc. In such scenario, you normally compile a code, meaning you need a place where you store it in a proper file. You can't be typing all of that in a command prompt. It doesn't work like that. So as I said, interactive mode is for a purpose, and for short programs it can be used, and it helps to see your outputs. And I think at this age of your standard, I think it's easy to use. And the second mode is a script mode. It can be written and stored in a separate files, and always these files are stored with .py. That's a specialty. So if I write the program in an ideal environment, and then I want to save that program, I can give just an example, demo1.py. So that means it's a Python file. So like if you write a Java program, it produces some files called .jar, jar file. So every programming languages have some extension. So and hence Python also has some kind of extension. So in this case, what you're doing is you're writing the program like you are seeing in the screen below. So where I've just done an increment function of x value by 1, and then later I was also doing a decrement by -1. And for the x, which is an input value, you can easily send a value. X can be any value you can send, and then you can print that value. So and that's that program you're seeing in the screen, black screen. But this program, what we wrote, we can save as a file like demo1.py. And what is the advantage of it? When anytime you want, you can reuse this code. Like today you done it, save it, go, and then tomorrow you come back. If you want to bring the same code again, you can rerun it. That's a big advantage. In interactive mode, it's just for that moment. Once you're done, that's it. You close the mode, you're done. Whatever you're done will vanish. But if you save it, your program in a py file, it stays and you can reuse it in future. And mostly in job, in our IT jobs and computer programming world, we always have this concept that the script mode is used for programming long and complex programs as well. um, it's also compiled. The compilation is important, as you know, for any programmer and a programming language actually. Okay, so yeah, so basically there are two modes, interactive mode and script mode. So remember that. Okay, let's move to the next one. Okay, like any function, we've discussed a little bit about this in function chapter. um, every when you build a function, there are certain variables you can use and there are certain system functions you can use as well. And this talks about that. So there are two type of functions, obviously, but the input function is about, which helps to enter a data at runtime by the user. So for this is normally used for, okay, if you want enter you want the user of the program to enter something, then you can design your program like that. So for example, you can see if I run this program in interactive mode, you can see that command prompt, and then I've created a variable called first name, which I'm asking to input saying, okay, enter your name. That's the message I'm displaying. So when you run that command, automatically in the screen you're going to say enter your name, and you can type in as a user, it will wait. Okay, I'm typing Tom here, or I can you can type your name there. And then if you want to see what it is, computer now would have stored that value in the memory, what you type. Now, if you want to see what it is stored, you can do an output function. So print function is quite common. You've seen many examples. Print is one of, is categorized as an output function. So so when you print my name is, that's just put some static text, right? You put it in double quotes, and first name is your variable name, then it's going to display as my name is Tom when you execute this program. So you can either do this in a script, as in, even you can do this in a script mode and save it, or you can do it in interactive mode. Okay, I've given some more examples with the input and output, but the important thing I want you to focus on this second example is a couple of things. One is the hash. It's called hash, where you can see the green colored highlighted ones. Hash, this is a comment, and below is one more of example of the input. So comments are important. So because the hash symbol is used in this program, and mostly I've seen similar hash symbol is used in other programming languages too. So comments help to read a program better, especially for any programmer, another programmer coming and opening this program in future. They can see, oh, okay, this is what this programmer in the past have done it. So this is what the example you're seeing is very, very simple example, basic ones. But in real life at work, we actually write very complex programs, and we need to see sometimes what's the reason why that logic is written and stuff like that. So a lot of programmers have the style of commenting it. So when you comment something, obviously when you execute the program or compile the program, the interpreter of the compiler will ignore that, and meaning it will not treat that as any command. It knows it's a comment, and it will skip that and move on to the next statement. So the next statement here is, we have allocated a variable called x with the integer value, and I wanted an input of enter number one. Because it's a number one, I've given a data type of int. We'll see, talk about the data types later. Similarly, for a y variable, I've declared it and enter number two, and then I wanted to print a sum of it, and it's very straightforward. I can see you can enter any values you like in enter number one and enter number two, and it flashes on the screen. And the answer in this case, I have put 5 and 10, and so hence the sum is 15. So you can test this program. Is such a very simple program as well. There is one another concept called indentation, which I've added in the end. So normally Python uses white space, such as spaces and tabs, to define program blocks. So what does that mean? When you're writing a program, it needs to be easy to read, because and also you should understand when you're doing if else logic, where the if is coming, else is coming. So normally we use spaces and tabs, in if you see in your laptop or a computer keyboard, it's normally used to make the program not only beautiful, but for easy readability as well. Okay. And they also have to block it. Okay, they so that when there is blocking, it's like typing a letter, right? You want to make sure it's really easy to read, and as well as the logic is flowing easily as well. So, and then when they do that, they will also add a programmer will add a comment where needed. So it's just something, it's a style of writing really. Some people don't do indentation, but look, when they don't do it, it makes our life harder for a reader, for a user. And hence it's highly recommended to follow those best practices when you're writing programming languages. It's not only applicable for Python, any programming languages. Indentation is very important. It's a method of, introducing extra space and tabs to make sure the programming is making sense and flowing correctly. Okay. All right. So let me move on to the next one. So we are going to see now more about tokens and token types. Okay. The tokens are, they are nothing but each logical line, meaning each line in a Python programming, is broken into a sequence of elementary components known as tokens. Um, because they call them as tokens. And then how they're classified, so they have like 5 to 6 different types of token types. To compare, a program is composed of many things, as you have seen lots and lots of examples. You will have to declare variables, then you need to put logic on. If you have to calculate something, you need to put the correct arithmetic operators to do it. Let's say you need to get some values, you need to use the right keywords to use it, so all that will make a program successful, right? So that's what token types are about. So what are those? First ones are identifiers. They are always used to, identify a variable, a function, class, object. Many examples. Again, it's about declaring something. um, Identifiers, normally we have always seen this, it cannot be a Python keyword, because Python keywords are nothing but system specific words. And like as I said in the past in other videos, every programming will have its own system specific keywords, and you cannot use those keywords as some kind of identifiers. Meaning, if you want to declare a variable, you should not use those values and use it, because the program, when you are compiling it, the compiler will get confused, just thinking, okay, what I'm supposed to do here. And hence that's the best practice. So you need to stay out of using any of the Python keywords. For that, you need to know what are all those Python keywords. So as you practice more and more, at one point you know which are all the keywords. If not, you can always keep a copy of the list of keywords somewhere handy, so you can refer to them, or you can also Google it anytime you want. I've given some example of valid identifiers, reg number, num1, first underscore name, all these are generic ones, no dramas. And when we do identifiers in programming, we try to give it meaningful, so that it's easy for readability. And when after 30 days you finished a program and you go back and look at it, it makes sense. Or if someone other programmer is reading it, it also makes sense for them. So there is a style in how you also give a name to an identifier, or give a name to a variable or an object. The invalid identifier, so these are like, okay, people try to avoid using numbers in the front, and then also like special characters like dollar symbol. Continue is like an operation, so that you won't allow those such words as well. Okay, so those are identifiers. So keywords, without keywords, there is no program in the world. So every program will have some kind of keywords, and I've just called out some of them. Excuse me. So class is a general one, a common one. Break, global. It's used for declaring a variable in, in a global location. Return is a common one, with while when you're doing looping condition, etc. So it's very important to know when not to use the keywords. Let's see more about other token types. The third one is the operators. The operators are symbolic symbols. They are special symbols which represent computations and conditional matching, like especially arithmetic, relational, and logical. Um, and the value of an operator used is called operand. So, for example, let's say you are doing an addition, and and you are doing a plus b. In this case, just an example. A and b are nothing but the operands. Okay. Um, and you can also do arithmetic. It's like mathematical arithmetics operations. You can do division. You can do a multiplications like star b is arithmetic, right? It's a multiplication as well. There are other types of operators like relational. This is more for comparison. Greater than equal to symbol, less than equal to symbol, or just greater than symbol between two variables. All those are and classified under relational. And the third one is about the logical comparison. So this is more on equal sign comparison. So compared to the above one, the relational one tried to do not equal to conditions as well. But logical is also almost similar to relational, but it's most of the A equal double equal to B is used. The fourth one is the assignment. Assignment is about, it's a shortcut. To be honest, if you wanted to do a like a repetitive incremental operation, you can just do use assignment operator. In this example, let's say I wanted to add mm, I wanted to do something like x is equal to x plus 30, right? So what we are trying to do here is whatever value you are passing to x, you are constantly adding by 30, and you can write a program to infinitely do it, or sorry, you can loop through, you can write a loop, multiply, do it until 1000 or until 2000, etc. A simple way of writing is x plus equal to 30. Okay, similarly you can do subtraction. So there's many examples in your books. You can use it when needed. Conditional ones are, it's about if some condition is met, then do this. If not, do something else. So in this, you can see a variable of min is assigned with 50 if 49 is less than 50. So that's a true condition, correct? If it meets, then it will give a min will be 50, otherwise 70. But now in the if condition, you got a fixed values like 49 and 50. But a lot of the times there will be variables like x and y there, and you will be passing values of x and y from some other functions in real world, right? In when you write a proper programming later. So anyway, so it's good to know different type of operators that will help you when you're writing a programming using Python. And then fourth one is delimiters. These are very common. Again, most of the programming languages use similar expressions, strings, etc. So, open brackets, comma, close bracket, plus equal to, less than equal to, all that symbols you've seen in the operators are there. And the colon, semicolon, comma, and curly brackets are also very important part of this token type as well. So this is delimiter example. So you will see more when you started writing complex programming using the delimiters. Let's see a next token type called literals. This is quite common. It's about how we use a variable or a constant value, or we call it data in IT. So any value you are getting is actually nothing but data element in a program, and the data gets stored in a database. Yeah, so that's something for you to know. So there are three types of literals. One is numeric, string, another one is strings, third one is boolean.
it's very straightforward. In even numeric, you got multiple types, like integer, float, and some more complex ones as well. So integers are nothing but pure numbers, like in max, whole numbers, and you won't have decimals, and floats will have decimals. That's the examples you're seeing there. In complex structures, you can do addition complex expressions with numbers attached to it. For example, you can say um, 3.14 multiplied by x or something like that. So the x will be a value you will constantly passing. So that's they will form a complex numeric output, right? So those are different examples of numeric ones. Um, Now the strings, very simple. We need strings, right? Because to put any statement, you need a string variable. The example I've shown is on str1. This is online video, and if you print that string, you will actually it will print as this is online video in your computer. And Boolean is very straightforward, like max, it's either true or false. So because in the previous slide we saw an example about an if expressions, where the answer can be true or false. So based on that, your programming logic will change. So and hence that's Boolean is very important. Last one, it's kind of more rather than a token type, it's more a escape sequence. This covers three different commonly used sequences. This helps the interpreter to understand what to do when you're running a program. For example, the backslash is a very common one. It's a special character, and it's also called an escape character. And another one's commonly used or tab. And when you want to give a tab space in a statement or something, you can use a backslash t with both quotes. Same way, if you are use backslash n with quotes, it's a carriage written for a new line. So in the example I've shown you, I've had a string of learning it. I want to print a string of learning is good, and then I introduce the backslash n in the middle, and which is usually insert a new line for you. This is quite commonly used in computer programming as well. So it's good to know these common escapes sequences when you're doing programming using Python. Okay, so now let's move on to the data types. I think I'm going to spend 2-3 minutes on this topic because a data type is almost similar to the previous slides we talked about, many slides, but they're trying to bring it all together in your book and explain this one more time. So every programming language will have data types, okay, and the common ones are numbers, strings, booleans, etc. The tuples lists are more specific to Python, because we have seen examples of tuples, where you have seen arrays and stuff like that, and the way how lists are also mostly like an array, but the way it is presented and stored is different, right? And dictionaries are more computer related dictionaries, or sorry, program. Some programs have their specific dictionaries which will have the reserved words, those system words, the keywords. It stores all that. So now we said Python is everything. It's an object oriented programming, so everything revolves around an object, and then object obviously will have a value, as well as that value will have a data type. What does that mean? A value can be a number, can be a string, or a boolean, or a tuple, or list, right? And that's what they mean by that. In general terminology, what is a data type? In any programming, a data type is a classification that specifies which type of value a variable has and what type of mathematical, relational, or logical operations can be applied to it without causing an error. So the mathematical operation includes those arithmetic ones which we saw, a plus, addition, subtraction, multiplication. So those are mathematical ones, right? We saw a few in a couple of slides ago, and relationals like greater than, equal to, and other logical operators as well. So the examples of them, one more time we are repeating this, but these all form under data types. Numeric ones, we saw integers, it can be any whole number, floating point numbers which have decimal values, and the complex numbers, you can have a big formula, right? Even if you do 3 plus 5y, or okay, 5x plus 2, you want to find some answers, and 2 times x squared or 2x, all these are complex value numbers, meaning obviously even in that example of that 3 plus 5 I is a variable, you'll be passing values and it will produce, when you print those statements, it will give an answer. Boolean data type is for true or false, which I said already. If a statement or an expression is true, then based on the true value, your program, you can write logic. Okay, if this is true, means go do that. If it's false, do that. So that's how it plays an important role. We'll see more examples in coming chapters. String is always used. This is mostly used for static values, like you're seeing there, and declare a school or a location, whatever you like. Those are also commonly used. So every data type is important, and you define the data type of a particular variable or an object based on what your program needs to do. You need to know the difference and then correctly define it, so that when you're compiling and the program and running it, the program interpreter will understand, okay, I know this data type and I'm going to process this and give you the required outcome. Okay, so it's very important that you understand the data type concept. And I think that comes to the end of this chapter. It's to some, and then I think it's very important you also spend some time doing some test practices using simple examples, using interactive mode and script mode in your computer. And there are lots of examples again given in your book. And in coming videos, we'll discuss more about control structures, other chapters, and Python functions, as well as some more about the strings. So I'm hoping to publish, if possible, both the videos on 6 and 7 together, but I'll keep you posted. So until then, as I said before, please forward these videos or links to the videos to your friends who are also in 12th standard as well as in 11th standard, who is going to start practicing year 12 syllabus later. And as well, if you have not watched the other 4 videos, I request you to go watch those 4 videos. Now it will make a lot of sense once you start getting into programming sub chapters in coming videos as well. Until I talk to you again, you all have a good day, and thank you for listening. Bye.